Colbeck's classroom style learning. All right, class. Now we're going to begin our concept map. I want everyone to look at their one term and define it and get it into me before the end of class. I'm here if you want to ask any questions. Oh man, I should have really studied before I came to class. I don't even know what the cell cycle is. Oh snap.
Professor,
Yes, Nabil?
I'm confused about this term.
What are you confused about it?
Everything?
Okay, let me walk you through it then. So what are the two phases in the cell cycle?
Mitosis and meiosis.
That's close. We have interphase and then the M phase.
Yes, sir.
So interphase consists of G1, which is the growth phase of the cell, S, which is your synthesis, your replication, and then G2, which is more growth of the cell. Now once interphase is done, do you know what happens in the M phase?
No.
So in the M phase, you have mitosis, where you have prophase, metaphase, anaphase, telophase, and then cytokinesis. Do you know what any of those mean?
No.
Okay, I'll explain those. Prophase is when the nuclear envelope dissolves and the chromatin become condensed. At the metaphase, the chromatin align at the metaphase plate. And anaphase, they separate through the spindle fibers. And then in telophase, the nuclear envelope comes right back, and then through cytokinesis, the cells are pinched and they turn into two replicated cells. Do you have any more questions?
No.
All right, good. Chapter 3, Virtual Outbreak Frustration. All right, guys, we're going to start Chapter 3, Virtual Outbreak now. First one to finish gets a bonus point. Oh, snap. Not this again. The virtual outbreak always gets my heart racing and I never win. Maybe today I'll win, but I really have no idea how to do this last problem. I'll ask the teacher. Yes, Mohsen.
Professor, I don't get this problem.
What do you not get about it?
Everything, to be honest.
Well, it just has to do with crosses. So, if you look over here, you have your 3 autosomal dominant genes crossing. What we can do is we can put these into monohybrid crosses, and each one of these letters, like big A, little a, will go right here, while big A, little a will also go on this side, and then we'll cross them. You know how to cross them, right?
Yeah.
Good. So once we've crossed them, we have our Punnett square. Now, with those letters in the Punnett square, we're trying to solve for what the probability will be for these genes for the offspring's recessive trait. So for this Punnett square, which one of these traits is the recessive trait?
Small a.
Yeah. So that gives us a fraction of 1/4. Now we'll go here. We're going to do the b's. So we have little b from there, and big B, little b from here. So I'm going to go ahead and cross these. Now, what are the autosomal recessive genes here?
Small a.
Small b, small b.
Alright, small b.
So that out of 4, 2 out of 4, because there's 2 small recessives out of 4, will give us a fraction of 1/2. Now from here, we'll do the same thing for C, which will give us,
Small c.
yep, which will also give us 1/2. So now what you do with these fractions is you multiply all of them together to get your answer. This is done through the multiplication rule.
Professor, I have the answer.
Yeah, Mohsen, what's the answer?
1/16. I'm done. I got it.
That's correct. That's a bonus point.
Yes, yes, sir! Yes, sir! Woo! Woo!
Chapter 4, Heads Up Confusion.
Professor,
Alright, what's it?
Yes, Nabil?
I don't understand this, man.
Well, what do you not understand about it?
I don't know the definition.
All day?
Well, let's think about it. You have sex determination here. The definition of sex determination is the mechanism by which sex is established. Does that make more sense about sex determination?
Yes,
Yeah.
sir.
Okay, let's move on to the next heads up term.
A couple of them. Yeah.
So over here we have genic sex determination. So genic sex determination is when male and females have no sex chromosomes, and genotypes that one or more loci determine the sex of an individual. Does that make more sense about how that one's done?
Yes, Professor.
Okay, let's move on to the last heads up term. So this is one of the harder sex determinations to know, but ZZ and ZW sex determination is mainly done in birds, reptiles, butterflies, amphibians, and some fish. It's basically when the male is homogametic and the female is heterogametic, as in the male contains the ZZ while the female contains the ZW. So, for example, in humans, females contain XX and we contain XY. So females are the homogametic while we're the heterogametic. It's the vice versa for this sex determination. There's a lot more types of sex determinations like environmental sex determination and so on. You should look into your modules and look over the terms for chapter 4 to learn more about sex determination. But I hope that helped.
Thank you, Professor.